Jupiter's Great Red Spot, a storm so vast and ancient that it has watched over human history, from the invention of the telescope to the first steps on the moon, is slowly disappearing. For centuries we thought of this crimson giant as eternal, a permanent scar on the face of Jupiter, unchanging and untouchable. But modern observations from NASA's Hubble Space Telescope, the Juno spacecraft, and generations of ground-based astronomers have revealed a shocking truth. The Great Red Spot is shrinking, and it's shrinking faster than we ever expected. This is not just a minor change to a distant storm. It is a planetary transformation that will rewrite what we know about Jupiter's weather, its interior, and the life cycles of the most powerful storms in the cosmos. Let us begin at the very start, with the first time humans ever laid eyes on this cosmic wonder. In 1665, the Italian-French astronomer Giovanni Cassini turned his crude telescope toward Jupiter and noticed a strange, persistent red blemish near the planet's southern hemisphere. He called it the permanent spot, and he recorded its position and shape with painstaking care. What Cassini didn't know was that he had discovered a storm system, unlike anything on Earth, a swirling vortex of hydrogen, helium, ammonia, and mysterious sulfurous compounds that spins counterclockwise, completing one full rotation every 6 Earth days. For more than 350 years, this storm has raged without stopping, making it older than the United States, older than the Industrial Revolution, older than every human-made structure on our planet. By the late 1800s, astronomers had measured its size at roughly 40,000 kilometers across its long axis, more than 3 times the diameter of Earth. Imagine looking up at Jupiter and seeing a storm so big that our entire planet could fit inside it 3 times over with room to spare. That was the Great Red Spot at its peak, a titanic, unchallenged giant of a storm, dominating Jupiter's southern cloud belts and glowing with a deep, rich red that fascinated every observer. For decades, we assumed this size would stay the same. After all, storms on Earth last days or weeks at most. How could a storm on Jupiter last centuries without fading? The first hints of trouble came in the 1930s, when careful measurements showed the storm was slowly getting shorter along its east-west axis. At first, the change was so subtle that few paid attention. Then, in 1979, NASA's Voyager 1 and Voyager 2 spacecraft flew past Jupiter and sent back the first close-up images of the Great Red Spot. Those images showed a storm, still impressive, but noticeably smaller than the 19th century records. Voyager measured the storm at about 23,000 kilometers long, already down by nearly half from its maximum size. The puzzle deepened. Why would a storm that had lasted for 300 years start to shrink? As the decades passed, the shrinkage did not slow down. It accelerated. By the early 2000s, the Great Red Spot was roughly half the length it had been a century earlier. Then, starting around 2012, amateur and professional astronomers alike noticed a dramatic shift. The storm's shrinkage rate jumped. Hubble observations confirmed that the spot was losing roughly 900 kilometers of width every single year. Its shape changed too, stretching less and becoming more circular. By the early 2020s, the long axis was just over 16,000 kilometers, barely big enough to fit one Earth inside. This was not a temporary blip. It was a clear, irreversible trend. To understand why this is happening, we have to look deep into the science of Jupiter itself. Jupiter is a gas giant made almost entirely of hydrogen and helium, with no solid surface to stop or slow its storms. Its immense internal heat, generated by gravitational compression as the planet formed, powers its wild weather systems. The Great Red Spot is an anticyclone, meaning it spins opposite to cyclones on Earth, held in place by powerful east-west jet streams to its north and south. For centuries, these jet streams acted like a cosmic cage, keeping the storm locked at a steady latitude and feeding it energy from smaller, nearby eddies. But now that balance is breaking. NASA's Juno spacecraft, which entered Jupiter's polar orbit in 2016, has given us our closest look ever at the Great Red Spot's structure. Juno's instruments revealed that the storm is surprisingly shallow, only about 200 kilometers deep thin, compared to Jupiter's 140,000 kilometer diameter, and that it is losing energy to smaller surrounding storms. These tiny eddies, once thought to be harmless, are now siphoning away the Great Red Spot's power, disrupting its internal dynamics, and robbing it of the fuel it needs to stay large. Another key discovery from Juno is that the storm is growing taller as it shrinks horizontally. As it loses width, it becomes more vertically compact, concentrating its remaining energy into a smaller area. This vertical shift changes the way heat and gases circulate within the storm, altering its color and its stability. The rich red hue that gives the spot its name comes from complex chemical reactions high in Jupiter's atmosphere, driven by sunlight and cosmic rays. As the storm shrinks and its structure changes, those chemicals mix differently, making the spot fade from deep crimson to pale orange or pink in some areas. Some images even show chunks of the red cloud breaking off and drifting away, like pieces of a fading painting. Scientists now predict that if the current rate continues, the Great Red Spot will become completely circular by roughly 2040. Beyond that, the future is uncertain. Some models suggest it could fully disappear within 20 to 50 years, dissolving into a sea of smaller, unremarkable storms. Others think it might stabilize at a tiny size, remaining as a small red blemish for centuries more. What makes this mystery even more fascinating is that Jupiter has a history of storm birth and death. In the early 2000s, 3 small white storms merged to form a new red spot, Juno, a smaller storm that briefly interacted with the original Great Red Spot. This proves that Jupiter's atmosphere is dynamic, capable of creating new storms, even as old ones fade. The loss of the Great Red Spot would not leave Jupiter calm. Instead, it would trigger a chain reaction across the planet's cloud belts. Jet streams would shift, storm patterns would reorganize, and new giant storms might emerge to take its place. This transformation matters far beyond Jupiter itself. Studying the Great Red Spot's decline teaches us about atmospheric dynamics on all gas giants, both in our solar system and in exoplanet systems, light years away. Storms are the weather systems of planets, and understanding how they live, grow, and die helps us understand how planets evolve over billions of years. For NASA and space agencies around the world, the shrinking Great Red Spot is a top priority. Every new image from Hubble, every flyby from Juno, adds another piece to the puzzle. We are not just watching a storm disappear. We are witnessing planetary evolution in real time, a rare and precious opportunity for science. Think about what this means for our place in the cosmos. For generations, the Great Red Spot was a symbol of cosmic constancy, a reminder that some things in the universe are too big and too powerful to change. Now, we know that even the mightiest storms have a lifespan. Jupiter, the king of the planets, is not static. It is a living, breathing world, constantly changing, constantly surprising us. As we look to the future, we can only wonder, what will Jupiter look like when the Great Red Spot is gone? Will a new giant storm rise to take its place? Will we see changes in Jupiter's magnetic field, its gravity, or its moons, as the atmosphere shifts? These are the questions that drive space exploration forward. Every time we point a telescope or send a probe to Jupiter, we are not just exploring a planet. We are exploring the fundamental rules that govern the entire universe. The Great Red Spot's shrinking is not an ending. It is a new beginning for our understanding of the largest planet in our solar system. It reminds us that the universe is always moving, always changing, and always full of secrets waiting to be uncovered. As we continue to watch and study this incredible vanishing storm, we stand on the shoulders of Cassini, of the Voyager team, of the Juno scientists, and of every astronomer who ever gazed at Jupiter and wondered. We are part of a 350-year journey of discovery, and the next chapter is just beginning. Please like, comment, share, and subscribe to the channel